Meet our latest project, Nubi. It's a 3D printed robot that's super easy to assemble, requires no soldering, runs on Arduino, and has Bluetooth compatibility. In this video, we'll show you how to assemble it. In our next videos, we'll program it and bring it to life. Ready? Let's go. Nubi is a fun and simple robotics project we put together for anyone who wants to learn how to build and program robots. Nubi has unique features such as an ultrasonic sensor for avoiding obstacles and a Bluetooth module for controlling movement. This is the first video of a multi-part series. Today we're focusing on assembling the robot. In our next videos, we'll dive into testing, coding, and adding cool features. We'll be sharing everything you need to build your own Nubi. You can find the 3D printing files and 3D printed parts on our website, the code on GitHub, and links to all the components and hardware in the video description. Most components can be saved for a future project, so nothing goes to waste. If you do not want to use the Nubi chassis, feel free to create your own design. You can apply principles learned in this video series, such as controlling a motor and reading values from a sensor to your own robot or project. Now that you have met Nubi, let's get building. Gather the 3D printed parts and electronic components that are provided in the parts list. The electronic components were selected so that no soldering is required. If you feel comfortable using a soldering tool, wire the robot as you see fit. You may already have materials such as wire nuts and zip ties lying around the house. The LED provided is pre-wired with a resistor. If you plan to use your own LED, remember to connect it in series with a 220 ohm resistor. The only tools required for the job are a small Phillips screwdriver, a small flathead screwdriver, wire strippers, a voltmeter, and glue compatible with plastic. A hot glue gun works well. Visit our channel to learn more about electrical components, such as the ultrasonic sensor and the servo. Remember to subscribe to keep up with the latest content in the world of electronics. Once we've checked that we have all our components, we can start the assembly process. First up, the motor plate. Locate your motor plate motor, two 20mm M3 hex standoff, and four 25mm M3 bolt. Step 1. Grab the two hex standoffs. Insert them into the holes on the motor support. Now, align your motor to the mounting holes and secure it with two bolts. Repeat this for the other side. Locate the motor driver, two 10mm M3 hex standoffs, and four 6mm M3 bolts. Fasten the hex standoff to the motor plate using the bolts. Once secured, fasten the motor driver to the motor plate using the remaining bolts. Take the swivel balls and glue it in place with any plastic-safe glue. Let it set for a bit. Once that's done, set your assembled motor plate aside. We'll come back to it later. Time to give our robot some personality. Locate the face, the eyepieces, the end caps for the eyes, the LEDs, and the ultrasonic sensor. Insert the LED into the eye end cap. Now find the eyepieces and the face piece. Insert the eyepieces into the eye locations on the face. Take your eye end cap with the LED and insert it into the eye cover. Then grab the ultrasonic sensor and push it into the sensor spot. Set it next to the motor plate for now, and we will come back to it later. Next, the robot's head. Find part 1 of the head, the robot's body, the on-off switch, the neck shaft retaining piece, servo and both servo retaining pieces. Install the switch by sliding it through the hole and fastening it with the ring. Now grab the neck shaft, push it into the head and lock it with the pin. Take your servo and attach it to the bottom of the neck shaft. Secure it with the retaining pin. Alright, let's connect the head to the body. Insert the neck shaft into the body, then attach the servo. Secure it with the retaining pin. Here's a tip. Make sure the servo's at its halfway point when the head faces forward, or turn it clockwise to the limit and install the head facing right. Let's get started on assembling our electronics board. We're putting together the brains of this project. Locate the electronics backplate, the power bridge, the breakout board for the Arduino, the power converter, 4 10mm M3 hex standoff, 8 6mm M3 bolts, and a zip tie. Now let's set up the backplate. Take the hex standoffs and screw them into the backplate using the bolts. These little guys will hold everything in place for our components. With the standoffs ready, let's move on. Grab your power bridge and line it up with the standoffs on the backplate. Secure it with 2 bolts. Do the same for the Arduino breakout board. Now let's focus on the voltage converter. Find it along with a zip tie. We'll need both. Before installing the voltage converter to the backplate, make sure the voltage converter output is set to 5 volts. Connect the battery connector to the voltage converter input and a multimeter to the voltage converter output. Connect the battery that will be used for the robot. Use a screwdriver and rotate the set screw until the voltage on the multimeter reads 5 volts. Once it's set to 5 volts, let's secure the voltage converter to the backplate. Use the zip tie to fasten it in place. Almost there. Let's pre-wire the components on the motor plate. Grab the assembled motor plate. Some lose 20 gauge wire and some jumper wires. At least 12 inches of wire is recommended. Follow the wiring diagram. Label your wires if needed so you do not lose track. Connect motor 1 red wire to out 1 of the motor driver and motor 1 black wire to out 2 of the motor driver. Now the other side, connect motor 2 red wire to out 3 of the motor driver and motor 2 black wire to out 4 of the motor driver. Connect a red 20 gauge wire to the 12 volt terminal of the motor driver and another one on the 5 volt. Add a black 20 gauge wire to the ground terminal labeled GND. Locate the jumper wires and connect them to in1, in2, in3, and in4. Once the wiring is complete, install the wheels so that we can connect the motor plate to the body. Time to install the motor plate to the body. Pull all the wires connected to the motor plate through the body. It may help to tape the wires together to pass them through. Press the body down onto the motor plate. Now locate the face assembly of the robot. Pre-wire the ultrasonic sensor using the jumper wires. Since we are not finishing the wiring, label or keep track of where each wire is landing. Install the face by lining it up with the head and pulling all wires through. Place the top edge of the face first, and then press the bottom portion down until it clicks. We are at the final stretch. Turn the robot around so we can install the electronics board. Pull all wires from the robot through the top opening of the electronics board. Align the electronics board with the back side of the robot head and press in the top and bottom until it clicks. Your Nubi robot is almost complete. Now that we have assembled the robot, it is time to complete the wiring of the electrical components. Let's start by addressing the power circuit. Loosen the power bridge and move slightly out of the way so we can make connections more easily. Cut and strip 2 small segments of 20 gauge wire. Connect one side to the voltage converter's out positive and the other side to any of the terminals labeled A on the power bridge. Now connect the out negative to any of the terminals labeled B on the power bridge. Locate the battery terminal and connect the battery ground to the in negative of the voltage converter. Grab a wire nut and connect the positive wire of the battery terminal to the red wire of the switch. Connect a small segment of wire to the in positive of the voltage converter. Grab another wire nut and connect the black wire of the switch and the wire of the motor driver that is connected to the 12 volt signal to the segment of wire connected to in positive of the voltage converter. Connect a small segment of 20 gauge wire from one of the power bridge B terminals and connect to one of the Arduino ground pins labeled GND. Connect a small segment of 20 gauge wire from one of the power bridge A terminals and connect to the voltage input pin on the Arduino labeled VIN. Locate all the black wires for the LEDs and connect each one to one of the B terminals on the power bridge. Locate all the red wires for the LEDs and connect in the following order. Top right to D4 of Arduino. Bottom right to D6 of Arduino. Top left to D7 of Arduino. Bottom left to D12 of Arduino. If one of the LEDs are swapped, we can fix it in the program later. Locate the wires for the ultrasonic sensor so we can complete the wiring. Connect the sensor VCC to one of the A terminals on the power bridge. Connect the sensor ground pin to one of the B terminals on the power bridge. Connect the trig pin of the sensor to pin D10 of the Arduino. Finally, connect the echo pin of the sensor to pin D2 of the Arduino. Time to complete the wiring for the motor driver. Connect the 5-volt signal to one of the bridge A terminals on the power bridge. Land the ground wire of the motor driver to one of the B terminals on the power bridge. Moving on to motor 1, locate the enable A signal and connect to D3 of the Arduino. Connect in 1 to A0 of the Arduino and in 2 to A1. For motor 2, connect the enable B signal to D5 of the Arduino. Connect in 3 to A2 of the Arduino and in 4 to A3. Now the servo. Connect the servo V positive or red wire to one of the A terminals on the power bridge. Connect the servo ground or black wire to one of the B terminals on the power bridge. Connect the servo signal to D11 of the Arduino. Last but not least, the HM10 Bluetooth module. Pre-wire the module with jumper wire and install into the location. Connect the module VCC to the 3.3V of the Arduino. Connect the ground pin of the module to one of the ground pins of the Arduino. Connect the RX to D8 of the Arduino and the TX to D9 of the Arduino. Carefully push all the wires inside the robot head through the hole of the electronics board. Locate the battery holder and install to the appropriate location. Locate part 2 of the head, which serves as the cover. Carefully press the sides to insert and lock into place. And that's a wrap. We have successfully assembled our Nubi robot. Watch our next videos so that we can code Nubi and bring it to life. See you guys next time. If you found this video helpful, please like, subscribe, and hit the bell notification button so you never miss an update from Noobotics. Follow us on social media for more behind-the-scenes content and upcoming projects. Thanks for watching. Remember, every expert was once a noob. Keep building and see you in the next video.